Algorithmic features are new in the December 2020 release of NX. In this demonstration, we're going to take a look at the basic interaction when creating a brand new algorithmic feature. The feature I'm going to create is an isogrid structure, something that is common within aerospace designs. In the graphics window, you can see the base geometry that I'm going to use for my algorithmic feature. In fact, I'm going to attach my isogrid structure to this conical face. So the first thing I need to do is to activate the algorithmic feature command. This takes me into the logic editor environment. You can see that we have a node explorer. We have a workspace that's currently blank, but this would include any of the nodes that we use to create our rule for our algorithmic feature. And we have a graphics window. And inside the graphics window, you'll see the result of the rule that we create. There are two buttons in the ribbon bar that are worth selecting. The first gives you previews of both geometry and node output. And the second one, associative, makes it an editable feature within the part history. So let's get back to take a look at the Node Explorer. In here, we have a list of all the nodes, and these are basically the building blocks that you use to construct your rule. The group below contains the rule inputs. This is where the rule author can define the view of the dialog that represents the rule, and it's what the end user will see in the modeling environment. The group at the top of the Node Explorer is for searching nodes, and it's a dynamic search, which means as you enter text into the search field, the results dynamically change depending on what you type. You'll see me using this later on in the demonstration. Now I'm ready to start constructing my rule. To start with, I'm going to add an input node, and in particular one that allows me to select the face to which I'm going to add my isogrid structure. So I simply pick and drag the select face node into my workspace. Each node has one or more ports, and these ports are used when linking between two different nodes. Now the port color is important. Here you'll see the face port is colored white, which means there's nothing inside that port that we can use to connect to a downstream node. However, once I select a face, notice that the port turns blue, which means now it contains information that I can pass on. Now the isogrid I want needs to be a triangular structure. So I'm going to search for a node that's going to help me create that form. Notice as I type, the list dynamically changes until I find the node that I need. Now I just double click it to add it to my workspace. Notice that the face port on the triangular grid is colored red, which means it doesn't have the required information to be satisfied. So I'm going to search for another node that's not only going to help me define my isogrid structure, but also satisfy the port in the triangular grid. I'm looking to utilize the UV parameters of the selected face, but from an earlier interrogation of the design, I found that the UV direction were not what I needed. In fact, I need to swap them. So I'm going to search for a node that will enable me to do this, and there it is, Transpose face parameters, and I drag it and position it in my workspace. Now I can start to connect the ports. Notice that when I select the output port on the select face node, it highlights input ports on the other two nodes that I could use. In this case, I'm going to select the input port on the transpose face parameters node. And you'll notice that when I do that, it turns green, meaning that it's satisfied. You may have also noticed a red cross appear in the triangular grid node. This means that in its current state, that particular node cannot provide any output. To fix that, I'm going to connect the output face port from the transpose face parameters to the face input port on the triangular grid. And now you'll notice that that port has been satisfied, and I've also got data in both of my output ports. Even though the triangular grid node has all the information it needs, it still has two empty ports. These are known as optional ports and don't have to be satisfied. For this rule, however, I am going to use them. So I'm going to use mouse button 3 and create an input for each of the ports. Mouse button 3 provides me with the opportunity to interact directly with the nodes within the workspace. Here I'm going to change the descriptive name for the two input nodes I've just created. The first one I'll rename longitudinal count, and the second one will be transverse count. And now I'll adjust the value in each one of those nodes. I mentioned earlier that the rule inputs can define a feature dialog, and we can see the current state of the dialog by selecting Edit Instance. Here you can see we have the Select Face option and inputs for both the longitudinal and transverse count. I can also preview the geometry I've created so far. If I select the magnifying glass in the triangular grid node, notice I can toggle on and toggle off a display of both the curves and the vertices. Now the triangular grid was created using the face parameters and also specified longitudinal and transverse counts. But now I need to make sure that the curves lie directly on the conical face, and to do this I'm going to add a project curve on face node. Notice there are two ports that need satisfying, so I connect the face port to our original face and the curve port to the curve output from the triangular grid. And there we have them both satisfied. We can take a look at a preview of what these projected curves look like. You can see that they're lying directly on the face. Now that we've got our isocurve grid network, let's look at adding some solid geometry. So I'm going to use a rib node to do that. So I'll search for it, find it, and then add it to my workspace. Once positioned, I can start to connect the ports. So I'll select the output face from our original node and connect that to the faces port on the rib. I'll take the output from the project curve on face node and connect those to the curves on the rib. And then I'm going to create two inputs, one for the rib height and one for the rib thickness. And I can rename them as we did for the longitudinal count and transverse count earlier. So I'll now add values for both the rib height and the rib width, and we'll zoom into the graphics area and then we'll preview the rib construction, and there you can see our solid geometry has been attached to the curve network. The rule stays dynamic in the logic editor, so if I make a change to any of the inputs, you'll see the effect straight away. I'm going to switch off the preview data, and now I'm going to interrogate the output before creating it. Here, using mouse button 3, I can select display data, and I get a list of all of the output information that I can expect when I generate it. Here, the separate window allows me to display this data, and I can scroll up and down and see exactly what I'm going to get. Finally, using mouse button 3, I'm going to create the output. And there I have my solid isogrid frame. So let's take a look at this algorithmic feature dialog. If I select the Edit Instance option in the Node Explorer, I get to see exactly what the dialog is going to look like. This is what's been built automatically from within the logic editor. Now the rule inputs group can control dynamically what can be seen within the feature dialog. Here, if I go in and hide two of the inputs, notice that when I take a look at the instance of my dialog, they've disappeared. I want to bring them back, so again, I just unhide them, and again, when we preview the algorithmic feature dialog, they're back in there. The rule inputs group also enables me to dynamically edit some of the values for my rules. Here, I change the number of the longitudinal count, and again, you see that dynamically update. It's very easy to interrogate nodes. Here, I select one and show its predecessors, and they're color-coded, and these are, if you like, the parents of that particular node. We can do the same for children nodes of that particular node. Again, just showing successors, and again, it's color-coded differently. If I want to tidy up my workspace display, again, I can just select Arrange Nodes, and it's automatically done for me, a far neater representation. So I'm happy with my rule, so I'm going to exit the logic editor. And now you can see the algorithmic feature has been created and is displayed in my part navigator. So how about if I need to modify the rule? How do I do that? Well, it's straightforward. Using mouse button 3, I select the algorithmic feature in my part navigator and select Edit Definition. It now takes me back into the logic editor, where I can make whatever change I need. In this case, all I want to do is to save the rule under a different name. So I select the folder that I want to place it in, and then specify the new name. I complete the Save As command, and then exit the logic editor. Now, when I go into my reuse library, where my algorithmic features are held, you notice now that that new Saved As rule is in the correct folder. That's the end of this algorithmic modeling basic interaction demonstration. I'd like to thank you for your time and attention.